We hear about AI literally everywhere, but is it always the right tool for the job? In this explainer, we're going to break down that fundamental choice in tech. Should you use a powerful AI, or is a simple, traditional system sometimes a smarter choice? Let's dive in and figure that out.
Okay, so let's start with a really simple example. Imagine you're building a password checker for an app. Right off the bat, you've got a big decision to make. Do you just write some simple if-then rules, or do you bring out the big guns and deploy a complex AI? That choice gets right to the heart of two completely different ways of building things.
And this really gets to the heart of our first big idea, the massive difference between programming with rules versus programming with predictions.
So with the traditional approach, think of the programmer as the architect. You are in complete control. You're the one writing the exact rules. Like, hey, if this password is less than 8 characters, reject it. And if it's more than 20, reject it too. The system, it just follows your orders, no questions asked. The outcome is always predictable, 0 surprises.
So, this old-school approach has a few key things going for it. First, the logic is all about those explicit rules we talked about. Second, the output is deterministic, which is just a fancy way of saying a 7-character password is going to get rejected every single time, no exceptions. And finally, that makes the whole system incredibly transparent. I mean, you can literally just look at the code and know exactly why it did what it did.
All right, so let's really put these two approaches side by side. Your rule-based system, it runs on rules we give it. But an AI system, it learns from data. A rule-based system is totally predictable, and AI is probabilistic. It's making a really educated guess. And that's exactly why AI is less transparent. It's not some magic black box, but you can't just point to one line of code to understand its thinking.
And hey, here's a little pro tip for you, especially if you're studying for any kind of certification. If you see a question on an exam that's describing a problem that needs a deterministic, rule-based output, well, that's your big clue. Machine learning is the wrong answer there. It's a great reminder that sometimes the simplest solution is truly the best one.
Okay, so we've established that AI is a totally different beast than your classic rule-based systems. But let's be real, AI is a massive term, right? So let's break it down. Let's take a look at the AI family tree and see how all these pieces fit together.
Right, so AI didn't just pop into existence overnight. It really evolved in layers. You have the huge, overarching idea of artificial intelligence that got its name way back in the 50s. Then, by the 80s, machine learning came along as a practical way to actually build it. In the 2010s, deep learning came along and supercharged the whole field, which led us straight to today's explosion in generative AI. See, each new idea is standing on the shoulders of the one before it.
So, at the very top of this family tree, you've got the big one, artificial intelligence, or AI. Just think of it as the giant umbrella term for any system that's designed to mimic human-like intelligence, whether that's recognizing a face, understanding what you're saying, or even playing a mean game of chess.
Okay, take one step down from that big umbrella, and you find machine learning, or ML. Now, this is a specific way of achieving AI. Instead of you, the programmer, writing a bunch of rules, you just feed the machine a ton of data and let it figure out the patterns on its own. It's all about learning from experience. And honestly, that's what makes it so incredibly powerful. And if ML is one way to do AI, then deep learning is a super specialized technique inside of ML. It uses this thing called a neural network, which, believe it or not, is loosely inspired by how our own human brains are structured. These networks have lots and lots of layers, which makes them insanely good at finding really subtle, complex patterns in just massive datasets.
Okay, so we keep talking about these neural networks, but what is actually going on inside of one? Let's peel back the layers, pun intended, and actually see how these machines learn.
To do that, we're going to use a classic example, teaching a computer how to recognize handwritten numbers. It's a fantastic way to visualize how a neural network actually thinks its way through a problem.
All right, so the whole journey begins at the input layer. This is where the raw data gets fed in. In our case, that's just the value of every single pixel from the image of a number. Then it gets passed to the hidden layers, and this is where the real magic happens. The first layer might just spot simple things like straight edges. The next layer takes those edges and combines them to find curves. The next layer might look for loops. It gets more and more complex with each step. And then finally, all of that processed information hits the output layer, which spits out its best possible guess. All right, I'm pretty sure that's a 7.
Okay, so that's a peek under the hood at the theory, but where do we actually see this stuff?
Let's take a look at some of the biggest real-world applications of AI that are all around us.
You know, most of the AI apps you see today fall into three big buckets. You have computer vision, which is all about teaching machines to see and understand images. You have natural language processing, or NLP, that's teaching them to understand human language. And then you've got the new kid on the block, generative AI, which is all about teaching them to create new things.
I bet you use NLP every single day, and you probably don't even realize it. It's the tech that lets Siri and Google Assistant actually understand what you're asking. It's the engine running behind all those customer service chatbots. It's even used to scan millions of social media posts to figure out if people are happy or angry about a new movie. It's everywhere.
And that brings us to generative AI, the one that's been all over the news lately. So, how does it work? Well, it learns all the patterns in huge amounts of existing data, like all the text on the internet, or millions of images, or tons of music, and then it uses those patterns to create something totally new. This is how it can draft an email for you, generate a stunning piece of art from a text prompt, or even compose a brand new song.
So after all that, we come full circle, right back to our original question. And honestly, it's the most important takeaway of this whole explainer. When should you actually use AI?
So here's the final thought I want to leave you with. Look, AI is an absolutely incredible tool. It's perfect for complex problems that are all about data and probabilities. But being a true expert isn't just about knowing how to use the biggest, most powerful tool in the toolbox. It's about having the wisdom to know when a simpler, more transparent, rule-based system is actually the smarter choice. Because the real key isn't just knowing when to use AI, it's knowing when not to.